Okay, so hello everyone. Today we will be solving question number 1331, which is rank transform of an array and is marked easy. And also it can be solved in two different approaches. And yeah, let's see what the question is about, and then we'll move on to the solution. Okay, so let's understand what the question is about. First of all, we will be given an array of integers ARR, and we need to replace each element with its rank. And the rank represents how large the element is. If higher is the rank, higher is the element. So here are the following rules. Rank must start from 1. So whatever we start ranking, it must start from 1. The larger the element, the larger the rank. If we are given two numbers, A and B, if A is greater than B, the rank of A must be greater than B. If two elements are equal, the rank must be the same. If same numbers are given, they must have the same rank and not the different rank. Also, rank should be as small as possible. Suppose we start the ranking from 1, and for the next element, we should try that the next rank we get is 2, not 3. So after 1, the next rank should be 2 and not 3. Suppose let's start from an example. Suppose we are given 10, 20, 30, 40. So which is the smallest element here? 10. So we must start the ranking from the smallest element. And what is the rule? That we should start the ranking from 1. So the 10 will be given the rank 1. Now 20. So 20 stands second in this order, in the ascending order. So we will give it 1. Likewise 3, likewise 4. But what if the given array is not sorted array? And let's suppose 40, 20, 5, 60. So we should think like 40. 40 stands at what rank in the ascending order? So if we were to sort, it would be 5, 20, 40, and 60. And in this case, for the 40 stands at third position. So 40 will be given the rank 3 because we must start from 1 and not try to skip the ranks, as we want to allocate the smallest possible rank as possible. So 40 stands third. So we will give 43. Here, this is the array given, and for our understanding, we have sorted this. And yeah, let's mark it as well. 55 is the first element, 20 is the second, 40 is the third, and 60 is the fourth element. So now when we are mapping, 40 will be given 3, 20 will be given 2, as it stands second in the sorted manner. Next is 5. We will check the original array for the correct answer, and for the rank we will check the sorted array here. Okay, so now in original array third index we have 5. So for 5 we have 1, rank 1 in the sorted manner, and for the 60 it will be 4. But what if we have two same numbers? So for example, let's take one of the given test case, which is 100, 100, 100. This is the original array. So we will also check how many distinct elements are there, so that no two numbers can get same rank. Means no two same numbers can get different ranks. So we will first see how many distinct numbers are there. Here we have only one distinct. And now we will sort it, and since it is 1, it is already sorted. 100 stands at the first position, and also our ranking must start from 1. So for the answer, we will check the original array. First is 100, which stands first in the sorted array. So 100 will be mapped with 1. Likewise, in the ordinal array at second index, second position, we have 100, which is also standing at first position in the sorted array. Likewise, for the third position in origin and 1. Also, let's take one more example, which is combination of distinct and same numbers like 100, 100, 200, 10, 50, 30, 10. So first we will check how many distinct numbers are there. Here the distinct numbers we have are 100, 100, but this is also noted once, so we will skip this. 200, 200, now 10, now 50, and 30. Also 10, but 10 is checked once, noted once, so we will skip this 10. Now we have got the distinct numbers, so what we will try is to get their position if they were in their sorted manner. So for that we need to sort them. So let's sort them. In for this we'll get 10, 30, 50, 100, 200, and in the sorted order we will check at what rank do they stand. 10 stands at the first position, 30 at second, 50 at third, 100 at fourth, and 200 at fifth position. So let's write here sorted. Now we want map the original numbers to their rank. So now we will check the original given array, which is here 100. 100 stands at rank 5th in the sorted, rank 4 in the sorted array. So 100 will be mapped with 4. Now we will check for this 100, which will also be mapped to 4, 200, which is standing at position 5, 10, 10 stands at position 1 in the sorted manner, 50 stands at position 3, now 30 and 10, 30 stands at position 2, and 10 stands at position 1. So our final answer is 4, 4, 5, 1, 3, 2, 1. So what should be our approach? Let's see. Our main concern is to first get all the, sorry, we need to know all the distinct numbers. Once we get the distinct numbers, we need to find where do they stand in sorted manner or ascending order. And once we get that, we can find their rank by assigning them in ascending order, and we must start with 1. So if we find all the distinct numbers, no two numbers, same numbers will have different rank. And if we start with 1, we also want to assign the smallest number possible. So once we assign a particular rank to a number, we will increment the rank by 1 so that the next number gets the smallest possible rank. So let's start its implementation using ordered map. This is our first implementation, and the second one will be unordered map and sorting method. Okay, so we'll first do the ordered map. So why we will be using ordered map? Because when we insert in an order map, the sequence is also maintained, not the insertion sequence, but they are internally sorted as well. They use red black tree, which maintains the balanced tree, and as a result, all are sorted in the map, which is not the case in unordered map. So while we use the ordered map, we do not need to explicitly sort the given array. So, yep, the space and time complexity, we will compare that as well. Yeah. So let's start. First, we get a map. We'll be using ordered map. Map int m. And we will also insert the given numbers in the map. As of now, we just want the distinct numbers. So for current case, we will just mark or assign each number with 1 just for the given purpose. So let's start for auto val array. This can also be done using I plus. So we will just insert in the map so that we are maintained with the distinct numbers and of I equals to 1 just for the pushing purpose. Now we will start the ranking. We will start the rank with 1, and to iterate map we will use iterators. We will declare or initiate the iterator using auto. And let begin so that we start with the first smallest number till the fact IT does not reach maps end. So let me explain what does this do. So when we insert this, what we are given here, when we insert this map array of elements, it is stored in a sorted manner and distinctively in the map 10, 30, 50, 100 and 200. So when we use uh, auto it equals to m dot begin, it maps to this 10. Okay, so the first, the rank will be stored in value. In map, it is key value and key is the distinct element. So we will assign the rank to the value. So star it dot second equals to the rank. So what we have done is we have assigned or associated one rank with the first element, which is it dot begin. Now we will, once we increment the it, we should also need to increment the rank so that 30 is mapped with 2 rank plus for understanding purpose cout star it per second rank. And now what we have done is map each value, distinct value with the ranks, and we have started with 1, and once the rank is assigned, we increment the rank. Now what we need to do, map the elements in given array, the array provided here with their rank. So we will first iterate the array and map it to the rank. So array of I equals to m of array of I. Okay. So for purpose, let's try return return the. Okay. Okay. It should be IT. Let's check. Okay, now it should work. Hopefully. Yeah. So here we can see 100 away. Here it should be first. Okay, so here you can see we have 3 numbers in an array, but in map only one is stored and it is mapped with the rank 1. So distinct elements are also stored and we have correctly ranked as well. Let's see in this case, map contains 10, 20, 30, 40, and our ranking manner is also correct. We have map 10 with 1, 20 with 2, 30 with 3, and 40 with 4. Now let's see. Yep, our solution is accepted, but it is a little slower because this ordered map takes time to balance the tree, and as a result, the time taken is more and is slower. So now what we will do is move to the second approach, which is unordered map with sorted array. So what we'll do is first create a duplicate array. Let's say CPY copy, and let's assign array to it. Now sort the duplicate array. So sort CPY dot begin CPY dot end. So as a result, we have sorted the array, which is here one of the main steps that we need to sort. But we also want listing numbers. If we were to sort this, it will be 10, 30, sorry, 10, 10, 30, 50, 100, 100, 200. But what about listing part? We have not filtered duplicates. So we have sorted, but now we need to create the distinction. So we'll first create an ordered map. So the main property of map is that it does not create duplicates and stores only the unique values. So now we will insert into the map and rank them accordingly. Since the array is sorted, which we want, we can also get the rank as per them. So start the rank with 1. Unordered map int m. So unordered map does not store the keys in ascending order. It just maintains the fact that only unique values are stored. If the same value is pushed once again, it does not include that. If it is to be updated, it will be updated, but does not include the duplicate element. So we'll push into the map and give the rank as well. Let's see how we will give rank. So what we need to do is check whether the current array element is inserted before or not. Because if it is inserted, we do not want to push that and give it a rank. Because if we have pushed 10 and given it a rank 1, and later in the array 10 is encountered once again, we do not want to push 10 with the rank 3. Okay, we do not want to update the older rank, which is to be 1 with a new rank, which will make it incorrect. So this should not happen. So we will check if the current element is not ranked. How we will check? By making sure that the current element is not present in map. Okay, so yeah, let's start. If m dot find, this is a method to find the key, which is the key here, array of find. If it is not present, f m dot find array is not equal to m dot end, which means that it is already present. So we need to skip this case. Continue. Since it is not present, this means that we can now assign a rank to that element. M of I equals to rank. Now update the rank. So the unordered map stores the unique values, and we only assign rank once by making sure that the current element is not present in the array, and we then increment the rank. So now let's update the original array. So we will iterate the array and map that array element with its rank. The rank is stored in map, unordered map. So array of I equals to the rank stored in the map, associated with it in the map. So now we will return array. Okay. What is okay? Here is a typo. Unordered map. Okay, what is the issue? 4123 vector int equals to copy. Where is the issue? We are sorting the CP by vector equals to. Okay, we made a mistake here. It should not be array here, but rather CPY, because we are dealing with copy array, which contains all the sorted elements. So that was the scenario. Yep, that's the thing. What was the issue here was like the original array was 100, 100, 200, 50, 10, 10, 30. Now we created CPI and sorted it. So CPI was 10, 10, 30, 50, 100, 100, 200. So what we needed was to iterate this CPI so that the ranking was done in the correct manner. That 10 was associated with 100, but our typo was the fact that we were iterating array, which was this. So what happened was, when we encountered 1, we gave the priority to 1. So it should not have happened. Instead, we need to iterate CPI. So that stuff happens. Don't worry. Hopefully, I guess that this question was helpful and the approach was also helpful. And if you have any doubt or anything, any suggestions or anything like that, please be free to comment, and any questions or any other little questions, to let me know. I'll be trying to upload more questions with the perfect approaches. Yeah, thank you. Just drop your feedbacks in the comments.